Let's do some examples. So here are some example 2x2 matrices that could be the Hessian matrices of some function, and we want to calculate the second derivative test. For each of them, we go through, we write down the little 1x1 corner and calculate its determinant, which is just the same as writing the number back down. And then we go through the little 2x2 matrix and we calculate its determinant. In this case, the determinant is 3 minus 2, so this is -1. So for this one, we get 1 and then -1. For this one, we get 2 and then 5. For this one, we get 2, and then we get 16 minus 16 is 0. For this one, we get 0, and then we get -1. And for this one, we get -1, and then 0 minus 1 is -1. So all we really care about for the second derivative test are whether these are positive, negative, or 0. So this one's positive, negative. This one's positive, positive. This one's positive and then 0. This one's 0 and then negative. And this one's negative and then negative. So some of these are easy. This is the easy case. This is a local min because we get positive and then positive. That's the only easy case on this list because we don't have any others that go positive, positive, and we don't have any others that start negative and then do positive. They alternate. Then we check for when the test fails. The test fails if it looks like we're on track and then suddenly we fall off a cliff and we get a bunch of zeros afterwards. That's this case. Here, we've got failure of the second derivative test because we get a positive that's on track to be a local min, but then we get 0 and we're done. So this is failure. All three of the rest of these, because they're not like that, these are all saddle points. And in fact, saddle points are way more common in general when you write down random matrices, or they have a tendency to be more common. Let's do some 3x3 examples. So for 3x3 examples, we've got 3 determinants to do. For this one on the left, we got this little 1x1 determinant gives us the number 2. And then this little 2x2 determinant gives us 4. And then this little 3x3 determinant, if we calculate it properly, we're going to get 2 times 2 minus 9 is minus 14. So that goes positive, positive, negative. That's not definitely positive, and it's not alternating negative, positive, negative, positive, and it doesn't fall off a cliff and eventually becomes 0, so this is a saddle. Here, this one, we get -1 as our first determinant, and then we get -1 times -1 minus 0, so that's +1, that's our second determinant. And for our third determinant, I will hope that you'll believe me that if you calculate it out, the third determinant is 1. You should check that. And so this is negative, positive, positive. This is also a saddle. For this third one, if we get 2, and then 2 times 1 minus 2 times 2 is -2. And then our third determinant is going to take a little bit of work to do as well. So it's going to be 2 times the determinant of 1, 1, 1, 2 minus 2 times the determinant of 2, 1, 0, 2, like so. So this is 2 times 2 minus 1 minus 2 times 4 is 2 minus 8, it's minus 6. So this one is positive, negative, negative. So in this case, all 3 of these are saddles. None of them is positive, positive, positive. None of them is negative, positive, negative. And none of them falls off and eventually becomes 0.